Hi guys, today's lesson is on factoring the sum and difference of cubes. So this is new to us. We did not see this in Algebra 1. Just a reminder, your perfect cubes are listed right here. And in terms of variables, it's anytime it has an exponent that is divisible by 3. So when we look at the following formulas. If we were factoring something of the form a cubed plus b cubed, this is where we would factor it to a plus b. Those are the cube roots of each of those. And then the square of the first, the product of them together, and then the square of the last. Now you'll notice with the signs, it's the same, then it goes to the opposite, and then it's positive. Now coming over here with the difference of perfect cubes, it's the same idea, cube root, square product square, same sign, opposite, positive. So to help us think of the signs here, we're going to remember the acronym SOAP. SOAP stands for same, opposite, and oopsies, A stands for always, positive. Okay, so here's how this works. If I want to factor x cubed minus 8, I can take the cube roots of each of those, and I'm keeping the sign the same. Then I do the square of the first, product of the second, or product for the second term, ignore that negative, and then square of the last one. Same, opposite, always positive. So again, here's your AB, and it's A squared, AB, B squared. And that's the pattern. That's really all it is. Okay, so if I did x cubed plus 27, cube roots of each would be x plus 3, square, product, square, same, opposite, always positive. Okay, now same idea with something with coefficients in front. Cube root, cube root. Now here's where students tend to mess up. Remember that this is A and this is B. So that means when you do A squared, you're doing the whole product 4 squared, which is 16x squared. So square, product, square, same, opposite, always positive. And that's the factoring. Alright, so coming on down to number 4, cube root of 343. Might not know that one off the top of your head. But if I scroll up here, 343 is right there, and it's 7 cubed. So this would be 7. Now cube root, remember you're dividing by 3. So 6 divided by 3 is 2. Okay, cube root of 64 is 4. Divide that exponent by 3, so that would just be 1. And that's the first part of your SOAP. Now remember, it's A, B, A squared, AB, B squared. So when you square this whole first part, that's a 49x to the 4th. Okay? Our middle term would be 28x squared y. And then b squared, again, you're squaring this whole product. So this would be 16y squared. Same, opposite, always positive. Now when we look at number 5, 54 and 250 are not perfect cubes. Like if I go up and I look at my list again, it's not there. But what is something that I can notice here is that each of these is divisible by 2. And then that unveils our perfect cube. So I can factor out a GCF And there's my sum of two perfect cubes. So cube roots. Remember, you're just dividing those exponents by 3. And then square, which would multiply that by 2. Product. Square. Same, opposite, always positive. Okay? Ooh, that was a long one. So this whole thing is your factored form. Okay. I kind of bled into this next one for number 6, which I'll actually just do. Let's actually cross off 9. Let's do number 6 down below here. So this would be t minus 4/5. Okay. Just cube roots of the tops and bottom, and then square. Product. Square. Same, opposite, always positive. Okay. All right, last couple examples here. We actually did problems similar to this on our difference of two perfect squares day, where I told you guys, when you have something like this, let's just do a little substitution. Let's call that a. So this would be a cubed plus 27. And then I'll factor it as if it was a. Now, it's not really a though, right? It's x minus 3. So what you're going to do is then go back in and put the x minus 3 in for everywhere I see an a. And that would be your factored form. And you can leave it just like that. So then same exact idea for 8. Instead of x plus 2, let's call it a. Okay, so cube roots, and then I literally say this every time I'm factoring it. It's just the pattern, right? I do square, product, square, same, opposite, always positive. And then we just got to go back in and do some substitution. So a was x plus 2, really. So everywhere I see an a, I'm plugging in an x plus 2. My exponent got messed up. And that would be your final answer. Okay, so that's how you factor the sum and difference of two perfect cubes.